Students, today's agenda is to check homework. We'll be graphing vertical trigonometric transformations, and you will be able to work on 10.10. Today, students will be able to graph vertical trigonometric transformations, and vertical, it just means up and down. And so before we start, I want to show you a guideline. If you recall, in Math 2, we learned that when we have transformations, the whole number outside makes a vertical stretch or compression. The minus h, that will be a horizontal shift, and it's minus because it always goes to the opposite on x, and that's why it's horizontal, because x is horizontal. And k, which is adding or subtracting outside at the end as a constant, you have a vertical shift, and if it's positive it goes up, if it was negative it would go down. And so that's going to be very similar to when we see the transformations with trigonometric ratios. In here for a will be very similar to the vertical stretch or compress. In here we'll call it amplitude, vertical stretch or compress. If it's a whole number, it stretches. If it's a fraction, it will compress. B affects the period, and it should be horizontal stretch or compression. So in here, it's defined, the period is defined by 2 pi, which is the whole circle, divided by that value. Okay, and C is the phase shift, which is the horizontal shift, meaning moving left or right, which is the opposite. That's why it has a negative. And D is the midline or center line, whichever you want to use. And this refers to a vertical shift, meaning it moves up if it's positive or it moves down if it's negative. And for this lesson, we're going to focus only on the vertical transformation. So we're going to be moving our midline and the whole graph with it. And also we're going to be stretching or compressing the amplitude of cosine and sine. I was filling out this by myself, but I think I want to show you the easy way to get to the values. What I do is, this is 0, and then I put 2 spaces for each value on y, 1, 2, 3, and I put negative pi over 2, but then I go negative pi, skip 1, negative 2 pi, skip 1, and that will be negative 3 pi. That's the easy way to get to those values. And then from here, these are going to be halves. So it's 1/2. This will be 2 halves, which is 2 divided by 2 is a whole thing. And so this will be negative 3 pi over 2, 4, 5, but negative pi over 2. And so that's easier to just get to those values. Again, the first one is just pi over 2. The next one is pi. But for the next ones, I just do the whole ones first. So skip 1, 2 pi. Skip 1, 3 pi. And then for here, I do the halves. So 1, 2, 3 halves. 5 halves, because it's 4, 5. 6, 7. So the ones that I skipped is only 1, 3, 5, 7. Okay, so that's the easier way to just remember those. And so for the mother graph, which would be the mother graph or parent graph, would be f of x equals just sine of x. So if you recall, and what I recommend is, well, the sign is 0, 0. You go positive 1, 0. For the next one, negative 1, 0. Positive 1, 0. And on the other direction, you continue that pattern. So it's now negative 1, 0. Positive 1, 0. Negative 1, 0. Those dots help me because I can make mistakes if I don't guide myself by points. Remember that For me, it's easier to graph from the highest points and then going down, because I just do a little round and then go round and go round and go. So that's just me, okay? So you might find it easier in a different way, but I just graph from the lowest point and go up, from the highest point and go down, highest point, go down, and so on. Okay, so that's my mother graph. Now for this function, what we're doing is that we're going to be just moving D. It's a vertical shift. Because it's positive, it means that it's going to go 2 spaces up. But what we're going to guide ourselves is with the midline. The midline is going to be right here. Okay, so that's my midline, or center line also. And that is going to go 2 spaces up. So 1, 2, right here. So it's going to be, the midline will be at 2. Positive, because this is positive. If it was negative, then it would go down. Okay, after we have that, what we're going to do is that this 0, 0, it's not 0, 0 anymore. It's this same point. Let's pretend that this is our 0, 0 now, okay? And this point will also go, since it went 2 spaces, this will also go 1, 2 spaces up. 1, so we're getting those critical points 2 spaces up, okay? So this one is a 0, it's right here. This one is below 0, so it's -1, but it still goes 2 spaces up. 1, 2. This is a 0, 1, 2. This one, 1, 2. And then from there you can even just see, oh, a 0, 1 up, 0, 1 down, 0, 1 up, 0, 1 down, okay? Or you can continue to count from here, 1, 2, okay? And the same for the other side, so 1, 2, 0, it's right on the line, 1 above, it's right here. This one, it's 1, 2, right here. This one, 1, 2, right here. And 1, 2, right here. And again, for me, I mean, some people find it easy like that. I can't do that. So I prefer to take my time and just drag it from the highest or lowest points. So for this one, it's a vertical shift. It moved up because it's positive. And it's D, is a constant at the end, okay? Okay, and so that's it for number 1. So my whole graph moved up with the midline or center line, okay? That's what we're doing with D. Okay, number 2. For this one is f of x equals cosine of x minus 4. So now we're subtracting 4, again is at the end, which is, once again, moving the midline, okay? And because it's negative, it's going to go down. In here, I already did previously the graph for you, the mother graph. So let's start by drawing our midline or center line. And again, that's going to go down 4 spaces. So 1, 2, 3, 4 spaces. And I noticed that I'm barely gonna have space but that's okay. So what that means is that each of these points will also go 4 spaces. So this will go 1, 2, 3, 4 right here. This is at 0, it's right on the line, so it's going to go on the line, and it's aligned to the x because we're not moving anything on x, okay? This is below the line, 1 space, and that's right there, okay? For this one is right on the line, so right there. This one is above the line, 1 space. This is right on the line. This is below the line, again, barely fits. and this one is right on the line, okay? Or you can just count 1, 2, 3, 4. For this one is right here, right? That point is right here. So 1, 2, 3, 4. For this one, 1, 2, 3, 4, and so on. Okay. On the other side, the same thing. This is right on the line. This is one line, one space below the line, the midline that we moved. This is right on the line, and this is one space above, so right there. Again, we just connected. For me, it's easier to go from the lowest or highest point, and that makes my life easier. Okay, and so that's your cosine of x minus, you move the entire graph of cosine 4 spaces down because it's negative. Number 3, we have f of x 2 cosine of x. Now you can see that the 2 is to the left of the trigonometric ratio. Okay, and so that's an amplitude. That means that it stretches. When it's a whole number, it will stretch. It's like you're pulling vertically. You're pulling those points. If it was a fraction, then you're going to compress, make it closer to the midline. And so in here, this number tells you by how many spaces you're going to be multiplying. And so the amplitude here is from the center line to any point, but it's going to be in the absolute value, actually. And so from here to here is 1. Multiplied by 2, it's 1 times 2 is 2. So my point is not going to be here anymore. It's going to be here. In here, it's negative 1 times 2 will be right here. Okay, so, and 0 times 2 is just stays as 0, so we're not going to change that. Okay, so again, this is 0, 0 times 2, 1 will be there for 0, 0. So in here is 1, twice of that is negative 2. For this one, it stays at 0, 0. This one is stretching to negative 2. This stays in 0, and this will stretch to positive 2. So that's going to be your new graph. And again, I'm going to go from the lowest point and pull it over here. Again, you can do it however is better for you. But for me, it's easier to just grab it from the highest point and pull it down, or from the lowest point and pull it up. Okay, and that way I'm going to be doing each one. And that's going to be my vertical stretch. You're stretching it up and down, actually, because if you notice from the center line, it grows up and it goes down. Look at the difference between the mother graph or the parent graph and this stretched version of cosine. For the next one, we have f of x equals negative 3 sine of x. So the negative is a reflection and 3 is a vertical stretch. So there are 2 things that you're doing to each point. So let's do the midline. And from that midline, you're going to do 2 things. Each point is going to stretch, multiplying by 3, and then reflect it on the other side as if this was the lake. You're outside, so you're reflecting. You don't have a mirror at home, so you go and check yourself on the lake. This is the water that you're going to be looking your reflection on. Meaning, if you're on top, you're gonna show at the bottom. If you're at the bottom, it goes up. Okay, but what I prefer is for us to do first the stretch and then the reflection. So for 0, 0, it just stays there. For this one, the amplitude is 1 times 3 is 3. So right here, but then it says do the mirror. So it's going to go all the way. It will reflect all the way down here. because of the negative, okay? In here, 0, 0 will always stay the same if we don't have plus or minus in here, okay? And then for this one, it's negative times 3 is negative 3, but the negative makes it positive, so it goes here. That's a reflection. 0, 0 again is right here. For this one is 1 times 3 is 3, but then the negative is a reflection, so that makes it negative 3 right there. And this is 0 again. On the other side, this is negative times 3 is negative 3, but then the negative makes it a reflection, so you go up here, 0 for that one. For this one is positive 1 times 3 is 3, but the negative is a reflection, so it goes to negative 3 right here. For this one is 0, 0, and so now we start graphing. Whoops. Okay, just remember that the negative reflects the point, and the 3 makes it taller. It stretches on away from x. Stretches each point away from x, or away from the center line. Okay? So that will be your negative 3 sine of x. The 3 makes it stretch. The negative makes it reflect. Okay? So instead of going down, it reflects up. So here I'm doing the mother graph, which is sine. It starts in 0 and then up, down, up, down. In number 5. For number 5, we have f of x equals 2 sine of x minus 3. That's the amplitude, and that's a shift, a vertical shift. It's moving the midline 3 spaces down. Okay, so this will move the graph 3 spaces down, and this will multiply by 2, meaning that it's a vertical stretch. Okay, so the first thing that we want to do again is draw our midline, and we're going to move the midline 3 spaces down. So 1, 2, 3. My midline is now going to be down here. And so we're transforming the amplitude, and we're transforming the midline, right? We changed the midline already, 3 spaces down. Now let's multiply it by 2. So 0 times 2 is just 0. This is 1 times 2 will be here, but then you move it 3 spaces down. And I'm referring to this right here. This is the amplitude. 1 times 2 would be on 2 right here, but then moving that 3 spaces down will be 1, 2, 3 is right here. So what I'm doing right now, and I'm just going to show you before I continue on the other ones, is that now that not only moved down 3 spaces, but it also stretched to be twice as tall. Okay, for this one is going to be 0, so it's right there. For this one is negative 1 times 2 will be negative 2, but bring it down 3 spaces. 1, 2, 3 is right here. For this one is 0, so just bring it down exactly right there. For this one is 1 positive times 2 is 2, but bring it down 3 spaces. So the first thing I'm doing is just multiplying by 2. That's where it's going to be. And then bring 3 spaces down. 1, 2, 3 is right there. This is at 0, 0. 1, 2, 3. Or you can just say, oh, this is a 0, so it's just on the line. Okay, so let's graph it up to here to see how it looks. Okay, and so for this one again, you could just say, oh, it's 1, 2, 3, but you're not stretching it. If you want to first bring it down and then multiply by 2, this is how it would look. It's right here, 1, 2, 3. It's away from the midline 1 space times 2 is now up here or down here. Okay, so you're multiplying it and then counting that from the new center line or midline. Okay, so in here is 0. For this one is, if you want to bring it down first, you go 1, 2, 3. That will be the point. The amplitude is 1, but you multiply the second by 2, then it's right there, 1, 2. Or again, you can just multiply by 2 first. This is 1 times 2 is right here, and then just bring it from here 3 spaces down, 1, 2, 3. You get the same result. Okay, and then this is on 0, 0. And we connect our curves through each point, more or less. That's going to be our new graph. Okay, number 6, it's f of x equals -3 cosine of x plus 1. This is a reflection, a vertical stretch, and a vertical shift up. Okay, so this is going up. This is -3 is not going down. If it's on the left of the ratio, the trigonometric ratio on the left means a stretch or compression, not moving up or down or left or right. Okay, so this is 3 transformations actually. And so let's start by drawing our center line or midline. It says that our midline is going to go up 1 space, so it goes up. I'm gonna draw it solid so that we know that this is our new mid. What we're going to do now is that this point, since it's above the original mid center 1 space, so now that is going to be multiplied by -3. That means that I go back to my midline, and 1 times -3 is -3. So from the midline I count -3, 1, 2, 3. That's right there. That's my new point. So again, the other way that you can see it is that if that point is here, after we move it 1 space, right? It's 1 space up. But then you multiply by the 3. So 1, 2, 3. It's right here at 4. But then we're going to reflect it on that new midline. So since it's 1, 2, 3 spaces, now it's going to be 1, 2, 3 spaces. This is right at 0, so that means that it's going to be right on the line, on the new line now. This is below the original, so it's below, it will be right here. But again, we're reflecting it and multiplying by 3. So it not only goes to the other side because of the reflection, but multiply by 3. 1 times 3 is 3, so 1, 2, 3 is right there. For this one is right on the original line or the midline. So now it's on the new midline. This one is above the original midline, so the new point is going to be above the new midline, which is here. But again, it reflects to the other side and it multiplies by 3. So 1 times 3 is 3. 1, 2, 3 right here. The next one is right on the line, but now it's on the new line. Okay, right on 0, right on the new midline. This is below the original line, so this is going to be below 1 space. But again, it reflects because of the negative right here and multiply by 3. This times 3 is 3, so 1, 2, 3 spaces. This is a 0, so right here. This is above the midline, meaning it moves 1 space up, but then it reflects, and then it multiplies by 3. 1 times 3 is 3, so 1, 2, 3. This is right on 0. And then this one is below, but it reflects, right? It's a mirror. And then multiply by 3. 1, 2, 3 is right here. And then I just connect my points. So I start from the highest point, from the lowest point, more or less. And I think in here it helps a lot to use different colors. I know it can get a little overwhelming, but at the same time you say, oh, now that I'm graphing, I just connect the blue points, right? And that makes our lives easier. So what did we do here? Each point it reflected, that's why it's on the opposite side. Instead of going up or stretching up only, it stretches by going on the opposite side of X. It also stretched and it also moved one space up. Okay, so those are the 3 transformations. And so this is all for 10.10. We worked on it with the amplitude and the midline, which is all about vertical stretches, vertical shifts. Next, we're going to focus on this in the next video. But if you could give us a thumbs up, subscribe around here, check out the other videos on this playlist with the unit of trigonometric ratios. And this is the next video, which is going to be about horizontal transformations, these 2 right here. And now you're able to do 10.10 and have fun.